Welcome to Computer Programming, a short educational video by Tommy J. First, we will have a brief look into the history of computer programming, and then we will look at a couple of aspects in more detail. The Antikythera mechanism is an ancient mechanical computer designed to calculate astronomical positions and is regarded as the birth of programming. It was recovered at the start of the 20th century from the Antikythera wreck, but its significance and complexity were not understood until a century later. The construction has been dated to the 1st century BC. Technological artifacts of similar complexity workmanship did not appear until the 14th century, when mechanical astronomical clocks were built in Europe. The Jacquard loom, which Joseph Marie Jacquard developed in 1801, used a series of pasteboard cards with holes punched in them. The whole pattern represented the pattern that the loom had to follow in weaving cloth. Charles Babbage adopted the use of punch cards around 1830 to control his analytical engine. The first computer program was written for the analytical engine by mathematician Ada Lovelace to calculate a sequence of Bernoulli numbers. The development of computer programming accelerated from the 1750 to 1850, an era called the Industrial Revolution. In the late 1880s, Hermann Holrich invented the recording of data on a medium that could be read by a machine. After some initial trials with paper tape, he settled on punched cards. To process these punched cards, first known as Holrich cards, he invented the tabulator and the key punch machines. These three inventions were the foundation of modern information processing industry. In 1954, Fortran was invented. It was the first high-level programming language to have a functional implementation. The code is translated by a program called a compiler, which translates the Fortran program into machine language. The invention of the von Neumann architecture allowed computer programs to be stored in computer memory. Early programs had to be crafted using elementary operations of the particular machine, often in binary notation. Every model of computer would likely use a different machine language to do the same task. Later, assembly languages were developed that let the programmer specify each instruction in a text format, entering abbreviations for each operation code instead of a number. Entering a program in assembly language is usually more convenient, faster, and less prone to human error than using machine language. By the late 1960s, data storage devices and computer terminals became inexpensive enough that programs could be created by typing directly into the computers. Text editors were developed that allowed changes and corrections to be made much more easily than with punched cards. As time progressed, computers have made giant leaps in the area of processing power. This has brought about newer programming languages that are more abstract from the underlying hardware. Although these high-level languages usually incur greater overhead, the increase in speed of modern computers has made the use of these languages much more practical than in the past. These increasingly abstract languages typically are easier to learn and allow the programmer to develop applications much more efficiently and with less source code. However, high languages are still impractical for few programs, such as those where lower-level hardware control is necessary or where maximum processing speed is vital. Did you know? A high-level programming language is a programming language with strong abstractions from the details of the computer. In comparison to low-level programming languages, it may use natural language elements, be easier to use, or be from specifications of the program, making the process of developing a program simpler and more understandable with respect to a low-level language. Compiler versus interpreter. An interpreter translates some form of source code into a target representation that it can immediately execute and evaluate. The structure of the interpreter is similar to that of the compiler, but the amount of time it takes to produce the executable representation will vary, as will the amount of optimization. The following diagram shows one representation of the differences. Here are some compiler characteristics. Spends a lot of time analyzing and processing the program. The resulting executable is some form of a machine-specific binary code. The computer hardware represents the resulting code. Program execution is fast. Interpreter characteristics. Relatively little time is spent analyzing and processing the program. The resulting code is some sort of intermediate code. The resulting code is interpreted by another program, and the program execution is relatively slow. Object-oriented programming. A type of programming in which programmers define not only the data type of a data structure, but also the types of operations that can be applied to the data structure. In this way, the data structure becomes an object that includes both data and functions. In addition, programmers can create relationships between one object and another. For example, objects can inherit characteristics between other objects. One of the principal advantages of object-oriented programming techniques over procedural programming techniques is that they enable programmers to create modules that do not need to be changed when a new type of object is added. A programmer can simply create a new object that inherits many of its features from existing objects. This makes object-oriented programs easier to modify. To perform object-oriented programming, one needs an object-oriented programming language, or OOPL. Java, C++, and Smalltalk are three of the most popular languages, and there are also object-oriented versions of Pascal. Procedural programming is a term used to denote the way in which a computer programmer writes a program. This method of developing software revolves around keeping code as coincident as possible. It also focuses on a very specific end result to be achieved. Imperative programming is another term to signify the type of development. When it is mandatory that a program completes certain steps to achieve specific results, the code is set to have been written according to procedural programming. Software developers who program according to this concept usually write a preliminary plan in plain language prior to actually writing code. Procedural programming is often taught first to encourage thinking in terms of a series of necessary steps that must be taken to accomplish a goal. It is not always the preferred method of coding applications. Software that is highly complex can require literally thousands of lines of code, making it somewhat more difficult for a team of people or even an individual. Perl is a programming language which can be used for a variety of tasks. A typical simple use of Perl would be for extracting information from a text file and printing out a report, or for converting a text file into another form. But Perl provides a large number of tools for quite complicated problems, including system programming. If you have used shell scripts or similar Unix utilities for various purposes, you will find that you can normally use Perl for those and many other purposes, and the code tends to get more compact. And if you haven't used such utilities but have started thinking you might need them, then perhaps what you really need to learn is Perl instead of all these kinds of functionality. Perl is implemented as an interpreted language. Thus, the execution of a Perl script tends to use more CPU time than a corresponding C program, for instance. On the other hand, computers tend to get faster and faster, and writing something in Perl instead of C tends to save your time. C language is a general-purpose and structured programming language developed by Dennis Ritchie at AT&T's Bell Laboratories in 1972 in the USA. It is also called a procedural-oriented programming language. C is not specifically designed for specific application areas, but it was well suited for business and scientific applications. It has some various features like control structures, looping statements, arrays, micros required for these applications. The C language has following numerous features as portability, flexibility, effectiveness and efficiency, reliability, interactivity. A high-level programming language developed by Bjørn Strostrup at Bell Laboratories. C++ adds oriented features to its predecessor C. C++ is one of the most popular programming languages for graphical applications, such as those that run in Windows and Macintosh environments. Java is a programming language and computing platform first released by Sun Microsystems in 1995. It is the underlying technology that powers state-of-the-art programs including utilities, games, and business applications. Java runs on billions of devices worldwide, including personal computers, mobile and TV devices, ATMs, supercomputers, and many more. The language derives much of its syntax from C and C++, but has a simpler object module and fewer low-level facilities. Java applications are typically compiled to bytecode that can run on any machine regarding its computer architecture. Java is a general-purpose, concurrent, class-based object-oriented language that is specifically designed to have as few implementation dependencies as possible. It is intended to let application developers write once, run anywhere, meaning that code that runs on one platform does not need to be recompiled to run on another. Java is currently one of the most popular programming languages in use. The lowest level programming language, machine languages, are the only languages understood by computers. While easily understood by computers, machine languages are almost impossible for humans to use because they consist entirely of numbers. Programmers, therefore, use either a high-level programming language or an assembly language. An assembly language contains the same instructions as a machine language, but the instructions and variables have names instead of being just numbers. Programs written in high-level languages are translated into assembly language or machine language by a compiler. Assembly language programs are translated into machine language by a program called an assembler. Every CPU has its own unique machine language. Programs must be rewritten or recompiled, therefore, to run on different types of computers. This was another educational video brought to you by Tommy J. Until next time, see you and be safe on your computer.